Hey everybody, welcome back to Quantitative Reasoning. Today we're in Chapter 8 and we're looking at Section 8.1 and we're going to be talking about percent, sales tax, and discounts. Our objectives for this section are express a percent as a decimal, express a decimal as a percent, express a fraction as a percent, solve word problems involving sales tax and discounts, determine percent increase and decrease, and investigate some of the ways that percent can be abused. So we have got a lot to do. We've got a really full plate. Let's go ahead and jump right in. So let's start at the beginning. Percents are the result of expressing numbers as a part of 100. The word percent literally means per 100 or divided by 100. The percent symbol that we all know so well is used to indicate the number of parts out of 100 parts. Now, whenever we see a percent given with a percent symbol, if we want to do any kind of calculation with that, we have got to remove the percent symbol and express the number in decimal form. So to express a percent as a decimal number, first remove the percent symbol and then divide the number by 100. For a decimal number, this is done by moving the decimal point 2 places to the left. Now, don't do this as 2 separate steps. This is really 2 parts of the same step. So let's practice that on the next slide. So here is example 1. Express each percent as a decimal. And in part A, we have 19%. Now, whenever you can't see a decimal in a number, you always can assume that the decimal is at the end of the number. So what we're going to do here is rewrite the number without the percent symbol, and that means that the decimal will have to move to the left 2 places. It will move in front of the 9 and then in front of the 1, and that's 2 places. Now, whenever there's not a digit in front of the decimal, I always like to start with a 0, and that's just to make sure that the decimal doesn't get lost. When the decimal is first, it's easy for people to overlook it or for it to get blended in with something else in whatever's being written. So always put a 0 if there's not a number in front of the decimal. So we're going to have 0.19, and of course without the percent symbol. So 19% becomes 19 hundredths. Percent and hundredths both mean the same thing. They both mean divided by 100. Let's look at part B. So here we have 180%. So the decimal is here at the end of the number 180. If we move that decimal to the left 2 places, it will be between the 1 and the 8. And so then when we remove the percent symbol, we will write that 180% equals 1.80. And because that 0 is trailing, there's really no need to keep it if you don't want to. We could write 1.8. For part C, we want to convert 67% to decimal form. So again, the decimal is here at the end of the number. If we move it to the left 2 places, it will be before the 6. And then because the decimal is the first thing in the number, we want to put a 0 as a leading digit. So we will write 0.67. And don't forget, when you move the decimal back 2 places, you lose your percent symbol. And then for part D, 250%, the decimal again is here at the end. So we would move that decimal 2 places to the left, and that would put it between the 2 and the 5. So we will write 2.50, no percent symbol. And of course, 2.50 is the same as 2.5. So you can lose that trailing 0. Now let's talk about what happens when your percent contains a fraction. If a fraction is part of a percent, then we begin by expressing the fraction as a decimal, and we keep the percent symbol because we have not converted to decimal form yet. We're first going to convert the fraction to decimal form, but it's still part of a percent. Then we do what we did on the previous slide. We express the percent as a decimal number. So let's get a couple of examples for that. Here's example 2. This says express each percent as a decimal. And in part A, we start off with 1/4%. Now, you may already know that 1/4 is equivalent to 0.25 in decimal form. If you don't know what the decimal is, then you just get your calculator and you punch in the top number divided by the bottom number. So we would put 1 divided by 4 equals, and it will tell you 0.25, but it's still in percent form. See, all we have done is convert the fraction part of this percent to a decimal. Now we want to convert the percent itself to a decimal form. So we'll do the same thing we did before. We will remove the percent symbol and move the decimal 2 places to the left. Now in this case, because the decimal is in front of the 2, if we move it 2 places to the left, we're going to have to fill those places in with zeros. So if I move it once to the left, there's 1 0 there. And then if I move it a second place to the left, there will need to be a second 0. And then don't forget, when we write this down, because the decimal is the first thing in the number, we want to put a leading 0 in front of the decimal to protect it. So when we remove the percent symbol, we'll have 0.0025. Now let's just compare. So if our decimal was here in front of the 2 and we moved it 2 places to the left, then you see that it's in the right place, and of course we lost our percent symbol. Let's look at part B. So here we have 1/100th of a percent. 1/100th of a percent. So the first thing to do is convert this fraction 1/100th to decimal form, and you might already know that that is 0.01, but again, if you did not know that this fraction is represented by 0.01, you could punch in your calculator 1 divided by 100 and it would give you the 0.01. But we're still in percent form here, so now we've got 0.01%. Now to remove the percent symbol, I'll need to move this decimal 2 places to the left. That's going to cause me to have 2 additional zeros after the decimal. And then because the decimal is in front, we'll put a 0 in front of that. So we will have 0. Then 2 more zeros, and then our number 01. So 1/100th of a percent ends up being equal to 0.0001. And again, compare what we ended up with to our percent written in decimal form. So if the decimal was here and we move it 2 places to the left, you can see how that's correct. Okay, now part C, 62 1/2%. Well, we know that 1/2 is equal to 0.5. So 62 1/2% would be written as 62.5%. Okay, now to eliminate the percent symbol, we'll need to move our decimal 2 places to the left. So when we do that, the decimal will end up in front of the 6, and of course we'll want to put a leading 0 there. So we will put 0.625, and then we will no longer need the percent symbol. Okay, so now that we've done that, let's move ahead. Now let's talk about expressing a decimal number as a percent. So to express a decimal number as a percent, first we multiply the number by 100. That's the same thing as moving the decimal 2 places to the right, and we attach a percent sign. It's basically the opposite of what we did to express a percent in decimal form. So let's get a few examples of that. So here's example 3. Express each of the following as a percent. So here in part A, we have 0.47. If we move that decimal 2 places to the right, it will be after the 7. And so when we've done that, we'll need to attach a percent symbol. So 0.47 is equal to 47%. Now let's look at part B. So we have 0.023. If we want to put this in percent form, we will move the decimal 2 places to the right, and that will put it between the 2 and the 3, and we'll attach our percent symbol. So when we've done that, we will no longer need these leading zeros. So we'll write 2.3% In part C, we have 1.5. So to express 1.5 as a percent, we're going to take this decimal that's between the 1 and the 5, and we're going to move it 2 places to the right. That's going to cause us to have to fill in a 0. So we will write 150%. Now you can see how if the decimal comes after the 0, it's 2 places to the right of where it started between the 1 and the 5. And I also want you to notice that if you have a number in front of the decimal that's 1 or more, you're going to get a percent that is 100% or more. And let's look at part D. So we have 0.002. Now if we want to put this in percent form, we move the decimal 2 places to the right, and that will put it right before the 2. Now because I don't want to start with a decimal, I'll keep this leading 0 right here, but I won't need 3 of them, so I'll lose these other 2. So I will write 0.2%. Don't forget, after you move your decimal 2 places to the right, you must attach that percent symbol, or what you've done is just create a new number. Okay, now let's talk about expressing a fraction as a percent. And basically what we have to do here is first get our fraction into decimal form, and then put our decimal into percent form. So the first thing to do is divide the numerator by the denominator. On your calculator, you'll just go top number divided by bottom number equals, and that will give you your decimal number. Then you take that decimal and multiply it by 100, and again that is done by moving the decimal point 2 places to the right, and then you just attach the percent symbol. So let's practice that here on example 4. So first we've got 5/8. Now what you're going to do again on your calculator is just punch in 5 divided by 8 equals, and you will get 0.625. So this is in decimal form now, and we already know from example 2, I believe, that to get this decimal into percent form, we move the decimal 2 places to the right. That's going to put it between the 2 and the 5, and we attach a percent symbol. And of course then we won't need this leading 0 anymore. So we will write 62.5%. In part B, we have 3/40. So to get the decimal form of this fraction on your calculator, you'll punch in 3 divided by 40 equals, and you will get 0.075. Okay, now to put this decimal in percent form, we move the decimal 2 places to the right and attach the percent symbol. So that will give us 7.5%. Here in part C, we have an improper fraction. And so, of course, when we convert this to decimal form, it's going to give us a value bigger than 1. And so when we convert that larger than 1 number to percent form, we're going to get something more than 100%. Let's see what happens. So we're starting with 3/2. Let's type in 3 divided by 2. And, of course, that gives us 1.5. So this is our decimal number, and to convert this to percent, we move the decimal 2 places to the right. That's going to cause us to have to fill in with 1 0, and so we'll write 150%. Same thing almost here on part D, so we've got another improper fraction. This time we have 4/3. So when we type in 4 divided by 3, this time we're going to get a repeating decimal. It never ends. So what you have to do is you just have to decide how many decimal places you're going to keep. So let's go ahead now and move our decimal 2 places to the right. That's going to put it where there's 2 3s in front of the decimal and an infinite number of 3s after the decimal. So we will have 133.33%. I decided to keep 2 digits after the decimal. You could decide to keep however many you need for what you're working on. And when you're working in my math lab, they'll tell you how many places to keep behind the decimal. So always read your instructions in my lab. But I just decided to keep 2 here. And that could change for you depending on your situation. Okay, now we're ready to turn our attention to solving applied problems. So we want to be able to calculate sales tax and discounts that are based on percents. So we're going to start small, and first we're going to learn how to use the percent formula, and then we'll move on into some application problems. So take a look at this formula. A lot of applications involving percent are based on this formula, and it says A equals P times B. So what this represents is A is P percent of B. So we recognize that the word is represented by the equal mark here in our little formula. So the amount is P percent of some base. A is P percent of B. Now notice that when we put it into words, the word of is represented by multiplication. And we find that a lot in math. The word of usually represents multiplication. So keep that in mind. And now let's do example 5 together. So it says use the percent formula to solve each of the following. And in part A, we're starting with the question, what is 3% of 200? Now we just always want to remember that the word is represents an equal sign, the word of represents multiplication, and the word what is going to represent something that we don't know. So we're going to let X represent what here. So what is, we're going to write X equals 3% of 200. Now remember I told you that you can never do calculations with a percent symbol in place. So in order to do this calculation, we need to remove the percent symbol. In other words, we need to put this percent into decimal form. So we take off the percent symbol and we move the decimal 2 places to the left. So we move it from behind the 3 to in front of the 3 and then 1 more place. And so that's going to make us write 0.03 to represent 3%. And then 3% of 200 means we're going to take this decimal representation and multiply it by 200. So I want you to compare now. What is 3% of 200? X equals 0.03 times 200. See, if you can write down the equation that's represented by the words, then you know how to solve this. In fact, this one's already solved for us. The X is already isolated. All we have to do is work out what's written here. 0.03 times 200 is going to be 6. So we just found out that X equals 6. So now we know that 6 is 3% of 200. Let's try the same thing on part B. So what is 8% of 300? So we will write X equals 8%, but remember we have to put it in decimal form. So move the decimal 2 places to the left and get rid of the percent symbol. So we'll write 0.08 and then of 300, so times 300. So what is 8% of 300? X equals 0.08 times 300. And on your calculator, you can multiply this together and find out X equals 24. So 24 is 8% of 300. Okay, let's continue with part C. 3 is 60% of what number? So again, remember the unknown number we just represent with X. The is an equal sign, the of is represented by multiplication, and we have to put our percent in decimal form. So 3 is, we'll write 3 equals, and then 60% of what number? So put this in decimal form, we'll move the decimal 2 places to the left, and so we'll write 0.60 times X. So 3 is 60% of what? Becomes 3 equals 0.60 times X. Now you remember how we solved these earlier back in chapter 6, and so we need to isolate the variable here, so we'll divide both sides by 0.6, and then of course the 0.6 is divided out here, and we'll have X equals 3 divided by 0.6, which is going to be 5. So 3 is 60% of 5. Okay, let's look at part D. So we have 24% of what number is 40.8. Okay, so we'll do the same thing again. Our unknown is in a different position, but we'll still write our equation the same way we've been doing it. So take the percent symbol off of this 24, and so that will give us 0.24 because we moved the decimal 2 places to the left. So 0.24 of, so that'll be times what number, so that will be x, is 40.8, so equals 40.8. Okay, now to isolate the variable, we'll divide both sides by this coefficient, so divide both sides by 0.24. The 0.24s divide out from the left side, and that leaves us x equals 40.8 divided by 0.24, and that's going to be 170. So 24% of 170 is 40.8. Now, continuing with example 5, we have part E and part F. Notice that in both of these parts, we are going to be trying to find the percent. And so what we have to keep in mind here is that when we solve our equation, the answer we get is going to show up in decimal form, and then we will have to convert that decimal into percent form in order to answer the question properly. So we're still going to translate the words into the same equation that we've been using, and we'll just have this one extra step at the end because we're looking for the percent. So here we go. 3 is what percent of 15? So 3 equals what percent, so that will be our unknown, of 15. So that would be times 15. All right, so 3 equals our unknown percent, which is going to be in decimal form. So this unknown number times 15. In order to isolate this variable, we would have to divide both sides by 15. And of course, the 15s divide out here, and we'll get x equals 3 divided by 15, which is 0.2. And then to convert this into percent form, we move the decimal 2 places to the right and attach a percent symbol. So if we move this decimal 2 places to the right, we'll have 20%. So let's check it out. 3 is 20% of 15, and that makes sense. Okay, part F. What percent of 2.5 is 0.3? Well, 0.3 is going to be a fairly small percent of 2.5, so let's see what it is. So what percent, that would be our unknown, so we'll put an x, of 2.5, so that would be times 2.5, is 0.3, so that would be equals 0.3. Of course, to isolate this variable, we will divide both sides by 2.5, and the 2.5s will divide out from here, and we will have x equals 0.3 divided by 2.5, which on our calculator gives us 0.12. And when we translate this into percent form, we move the decimal 2 places to the right and add the percent symbol, and so we see that x is equal to 12%. So 12% of 2.5 is 0.3. Okay, now we just have a couple more different ones, and if you are feeling pretty comfortable with these, you might want to pause the video and try these on your own and see how it goes. Now let me go through it with you. Okay, 8 is 40% of what number? So I'm going to write 8 equals 0.4 times our unknown value. Now I divide both sides by 0.4, and we will have x equals 8 divided by 0.4, which is 20. So 8 is 40% of 20. Now that makes sense because 8 is less than half of 20. So it's certainly less than 50% of 20. So it makes sense for 8 to be 40% of 20. Okay, let's look at part H. 32% of what number is 51.2? So translating this 32% into decimal form, we have 0.32 times our unknown value equals 51.2. So 32% of some unknown number is 51.2. Divide both sides by 0.32, and that coefficient will divide out from the left side, and that leaves us x equals 51.2 divided by 0.32, which is 160. And let's just stick that number back in here and see if it makes sense. 32% of 160 is 51.2. Now that makes sense to me because 32% is a little less than a third, and 51.2 is a little less than a third of 160. So it makes sense to me that 32% of 160 is 51.2. Okay, now we've got a pretty good handle on using the percent formula here, and what we're going to do now is take this formula and use it to calculate some different values that we encounter in everyday life, like sales tax. So you already know that the sales tax is always calculated as a percent of the cost of an item. Here in Mississippi, our sales tax is usually 7%, but in some restaurants, in some towns, you might pay 9% tax or 9.5% tax. It just depends on the town. But it's always true that sales tax is a percent of the cost of an item. So we can say that the sales tax amount is going to be the tax rate, which is a percent, times the item's cost. And you see how that matches our basic percent formula. The amount is equal to the percent in decimal form times the cost. A equals P times B. Okay, so here is an example for us. This is example 6. It says, suppose that the local sales tax rate is 7.5%, and you purchase a bicycle for $183. How much tax is paid? Well, the tax that we pay is going to be 7.5% of $183. So what we're really asking is, what is 7.5% of 183? Now you know that in order to calculate this, what we have to do first is remove the percent symbol and move this decimal 2 places to the left, which is going to put a 0 before the 7. So what we're going to have is that our tax is equal to 0.075 times 183. So on your calculator, you can calculate this value, and you'll find that the tax is equal to $13.725. Now, our money system does not allow us to pay in something less than 100th. So if there's ever a number past the second decimal place, we always round off to the second decimal place. In this case, we would round off to 13.73. We always round off to the nearest cent when we're talking about money. Okay, so the tax on the bicycle would be $13.73. Now you know that you can't just pay the tax, you have to pay for the item as well. So in part B, where it says what is the bicycle's total cost, it's always the price plus the tax. So it will be 183 plus 13.73 for a total of $196.73. Now, we were asked 2 different questions. We were asked how much is the tax and then what is the total. So it made sense to do the problem this way. But a lot of times when you're in a store, you don't really actually care about the amount of the tax. You really are just interested in the total. So instead of doing 2 calculations here, instead of doing the multiplying step and then the addition step, what you can do for your own convenience is say, okay, I'm going to have to pay 100% of the price to get the item, and then I'm going to have to pay 7.5% to get the tax. Altogether, you're going to have to pay 107.5% of the item's price. So what you can do, if you just want the bottom line total price that you're going to pay, is you can say, what is 107.5% of this item's price? So you can say 1.075 times 183, and you'll just get the total right there. And I've already rounded it here. But you see how that saves you a step. So what you're really doing is you're doing the addition step in your head because it's easy to add percents, and then you're just doing your multiplying with the total percent times the price. Okay, so here's example 7. It says, suppose that the local sales tax rate is 6%, and you purchase a tablet for $1,260. First, they want to know how much tax is paid, then they want the total. So the tax is 6% of the $1,260. So we'll write that tax equals 6% of $1,260. So when we convert this to decimal form, it's going to be 0.06 times $1,260, and that tells us that the tax is going to be $75.60. Now, to get the tablet's total cost, of course, we will take the $1,260 and we will add the tax to that and get a total cost of $1,335.60. But also, just to practice with what we learned on the last slide, if you didn't really need to know the tax amount separately and you just wanted the total cost, what you could do is say, I'm going to have to pay 106% of the price of the tablet, 100% for the tablet and 6% for the tax. So I'm going to pay 106%. So I could just write that the total is 1.06 times the price of the tablet, and so there is again our total cost of $1,335.60. Now, of course, tax always gets added to the price, but we also frequently find discounts when we go shopping. And discounts, of course, are subtracted from the price to allow us to calculate a sale price. So the discount, again, just like sales tax, is a percent of the original price, and we will still calculate the discount amount the same way we calculated sales tax because it's still a percent of the original price. So the discount amount is going to be the discount rate times the original price, just like the sales tax amount was the sales tax rate times the price. So here is example 8, and it says a gaming laptop with an original price of $1,460 is on sale at 15% off. What is the discount amount? So again, just to translate this into the language of percents, what we're really asking here is what is 15% of 1,460? And so of course we would calculate this by saying the discount equals 0.15 times 1,460. And that will give us a discount amount of $219. So we're going to save $219 off of this original price. So of course the sale price is the original price minus the discount. So that's going to be the $1,460 minus the $219 discount. And so the sale price would be $1,241. Now, just like we saw with sales tax, you can save yourself a step here. We usually don't care what the discount amount is. We usually want to know, what am I going to end up paying for this item? So instead of calculating the discount and then subtracting, what you can do is subtract the percent in your head. You can say that since you're saving 15% off the price, you're going to end up paying 85% of the price, right? If we don't have to pay 15%, that means we do have to pay the other 85%. So I could just say that the sale price is 85% of the original, so 0.85 times the original, and that still gives me the final sale price. So just two different ways to do it. This one saves you a step when you're in the store. So again, if you are trying to answer a question like this one, you can calculate the discount and then subtract to get the sale price. Or if you just want to know the sale price, you can subtract percents in your head and do a percent for what's left. So like here I said I'm saving 15%, 100 minus 15 is 85%, and so I'm paying 85% of the price. I'm paying $1,241. Here's example 9, and I think this is a great opportunity for you to pause the video and try this one on your own. Okay, now I'll go through it with you. So example 9 says, noise-canceling headphones with an original price of $380 are on sale at 35% off. What is the discount amount? Well, we are saving 35%, and we will write that the discount is equal to 35% of 380, so that's 0.35 times 380. And so we find that the discount is $133. Now, the sale price will be the original price minus the $133. So that's going to be 380 minus 133, and so the sale price is $247. Or remember, we also have this shortcut way of doing it. If you're in the store and you just want to calculate the sale price, you say to yourself, 100% minus 35% is 65%. So I'm paying 65% of the price. And so 65% of 380 is 247, which is what we got for the sale price doing it the two-step way. Now let's look at example 10 together. So this is part A of example 10, and it says, what is the total cost of a $720 iPad that is on sale at 15% off if the local sales tax rate is 6%? So just like in real life, we frequently find things on sale, but even though we do get a discount, we still have to add sales tax to get a total price for the item. So what we're going to do is first calculate our discount, then get the item's price, then calculate the sales tax and get a total. Okay, so here we go. First, they told us that the item is 15% off. So let's calculate how much of a discount we will get on this $720 iPad. So our discount is going to be 15% of 720. So that's going to be 0.15 times 720, which is a total of $108 that we're saving on the iPad. Okay, so if that's the discount, then what's the price? What's the sale price? And the sale price would be the 720 minus the 108 that we're saving, so the sale price would be 612. Now this is the amount that we have to pay tax on, and so the sales tax will be 6% of 612, and that's going to be 0.06 times 612, which is $36.72. Okay, so our final price will be the $612 that we pay for the item plus the $36.72 of tax for a total of $648.72. Now that's the answer to the question. But let's see if we can do it our shortcut way, because like we said before, when we're actually in a store deciding if we want to buy something or not, we don't care what the discount is or how much the sales tax is. What we care about is how much is it going to cost me to walk out the door with this thing, right? So let's do it the shortcut way. If we're saving 15% off of the original price, then we're paying 85% because 100% minus 15% is 85%. So the sale price of the item is going to be 85% of 720. So of course you know that's going to end up being 0.85 times 720. But now the sales tax is 6%. So the total price to get out the door is 106% of the sale price. And like we said, the sale price is 85% of 720. So what we'll do is we'll do 1.06 times the sale price. So the sale price is 0.85 times 720. And so if we multiply 1.06 times 0.85 times 720, we will get the same sale price that we got with all of these other steps before. And so this might answer another question that some of you have had before too. I know you've probably been like, well, I've got this item on sale, but I'm going to have to pay tax. Would it be better for me to get the discount first and then add the sales tax, or would it be better for me to first calculate the total with tax and then take off the discount? Like, does it matter where the salesperson takes off my discount, at the beginning or at the end? Well, you can see here that it doesn't matter, because all that's really happening is you're multiplying the original price times two different numbers. So it really doesn't matter which number you multiply first. We know that multiplication can be done in any order, and so it doesn't matter at what point in the transaction the salesperson takes off your discount. Now here is part B, and this one is very similar to part A, so I hope that you'll pause the video here and try this on your own. Okay, now we're going to go through it together. It says, what is the total cost of an $850 TV that is on sale at 20% off if the local sales tax rate is 7.5%? Now, just to go through it step by step, what we would do first is first calculate the discount, then subtract the discount from the TV price, and that will give us the sale price. Then calculate the sales tax, then add the sales tax to the sale price. Okay, so let's do that. If we're going to save 20% on this TV, we're going to save 20% of $850. So 0.20 times 850 means we're going to save $170 on this TV. Now, 850 minus 170 means that the sale price of the TV is $680. Okay, that's the amount we're going to pay sales tax on. So how much is the sales tax? Well, it's 7.5% of 680. And so that's going to be 0.075 times 680, which is $51. And now the total price to get out the door with the TV is the $51 tax plus the $680 for the TV, and that is a total of $731. Now, if you want to, we can do this the short way. So we can say if we're saving 20%, we're going to end up paying 80%. So our sale price would be 80% of the original $850, and then we're going to have to pay 100% of that plus 7.5% more of that. So our total with sales tax is going to be 107.5% of the sale price. So that's 1.075 times 0.8 times 850 for a final price with tax of $731, just like we got the long way. Okay, now let's shift gears a little bit and talk about percent increase and percent decrease. So you already know, I'm sure you've heard it in the news, you've read it in articles online, percents are used for comparing changes. And so the way that we calculate a percent increase or a percent decrease is to make a fraction. And that fraction will always be either the amount of increase over the original amount or the amount of decrease over the original amount. But the important thing I want you to notice here is that the bottom number is always the original amount. It's not the new amount, it's always the original amount. So whatever the increase or decrease is, that will be your top number, and then the original number will be the bottom number. And then to get the percent increase or the percent decrease, you take that fraction and convert it to a percent. So on your calculator, you just do top number divided by bottom number, then move the decimal to the right 2 places and put your percent sign on there. So a lot of times we see percent increase or percent decrease as part of a report of some kind or a news article, and so that's kind of what we have here. In the year 2000, the world population was approximately 6 billion. The data in the chart are from the United Nations Family Planning Program and are based on optimistic or pessimistic expectations for successful control of human population growth. Part A, find the percent increase in world population from 2000 to 2150 using the high projection data. Okay, so come over here and look at the chart. Here is the projection that shows the most growth. So this is the high projection. So what they're asking us to do is find the percent increase that's projected on this model from the year 2000 to the year 2150. Now, this little balloon here tells us, because it's hard on a chart this size to read the exact number, but they're telling us that in the year 2000, the population was 6 billion, and in the year 2150, according to this projection, the population will be 30 billion. So to find percent increase, what we need to do is take the amount of increase and then compare it to the original number. Well, the 6 billion population was the original because that was the one that happened first. So what is the amount of increase here? Well, to find the increase, we just subtract the 30 billion that we finish with minus the 6 billion that we started with would mean a population increase of 24 billion. Okay, so now the percent increase is that 24 billion difference divided by the original number. So in this problem, the year 2000 data is the original, and so we divide by 6 Now these are billions, so 24 billion divided by 6 billion is 4. And to put that in percent, we move the decimal 2 places to the right and add the percent symbol. So that would mean an increase of 400%. Now let's look at Part B. So here in Part B we've got the same chart, but the question this time says find the percent decrease in world population from 2000 to 2150 using the low projection data. Okay, so again, in the year 2000, we're starting with a population of 6 billion. According to this low projection, the population could actually drop to 4 billion by the year 2150. So this time we have a decrease. So let's start by calculating the amount of the decrease. And that would be the 6 billion that we started with minus the 4 billion from the year 2150, which would be a decrease of 2 billion people. And then the percent decrease is the 2, because that's the change, divided by the amount in the original population, so the original number, which was 6 billion. So we've got 2 billion divided by 6 billion, and that is going to be 0.3333, repeating forever in decimal form. But when we convert this to percent, we move the decimal to the right 2 places and attach our percent symbol, and that's going to be a percent decrease of 33.33%. Now again, I kept 2 decimal places here because that just felt natural to me, but always read in my lab because they will tell you how many digits you need to keep after the decimal. So be sure and read for that information. Okay, now example 12, still working with percent increase and percent decrease. And it says, the bar graph below shows that life expectancy, the number of years newborns are expected to live, has increased dramatically since ancient times. Part A, find the percent increase in average world life expectancy from the Stone Age to the year 2016. Okay, so we can see on the chart here that for the Stone Age, the average life expectancy was 25 years. Let's go ahead and write that down. And then for the year 2016, the average life expectancy is 71. Now, it doesn't mean that the oldest people in the Stone Age only lived to 25. This is an average. So what it really means is so many people died young for different reasons that the average life expectancy was only 25. People then got older than 25, just like people today can live longer than 71 years, but it's an average. Now, there's obviously an increase, but now to calculate the percent increase, we need to calculate first the amount of the increase. So the first thing we'll do is 71 minus 25, and that gives us 46. So the amount of increase in the average life expectancy is 46. Now to find percent increase, we always divide by the original number, always the original number. So we're going to be dividing by 25. Because when you calculate percent increase or percent decrease, you know a percent is a way of comparing 2 numbers. And the number you're always comparing to is the one you started with. So in this case, the 25. So 46 divided by 25 gives us a decimal value of 1.84. If we put this in percent form, we'll move the decimal 2 places to the right and attach the percent symbol. So that would be a 184% increase in average life expectancy from the Stone Age to the year 2016. Then for Part B, same chart, find the percent increase in the average world life expectancy from the Stone Age to 1980. And so we still have that the Stone Age average life expectancy was 25, but for 1980, the average life expectancy was 61. And so the amount of increase is going to be 61 minus 25, which is 36. And then the percent increase will be that 36 divided again by the original average life expectancy that we're comparing to, which is the 25, and that would be 1.44 in decimal form, or 144% in percent form. Now in example 13, we're going to do the same kind of thing, but just with a retail example. So it says a television regularly sells for $940. The sale price is $611. find the percent decrease of the sale price from the regular price. So we can see from the problem that the original was 940 and the sale price is 611. To find percent decrease, we need to find the amount of the decrease, and then we compare by division to the original price. So the amount of the decrease is 940 minus 611. So the price dropped $329. Compared to the original price, 329 divided by 940 is 0.35, which in percent form would be 35%. So there's been a 35% decrease in the price. And here's example 14. A pair of shoes regularly sells for $135. The sale price is $60.75. Find the percent decrease of the sale price. So, of course, we know that what we need to do is first calculate the decrease and then compare to the original price. So the decrease will be the $135 that we started at minus the $60.75 that we ended at. That's a decrease of $74.25. So the percent decrease is that $74.25 divided by the 135. That gives us 0.55, and then we convert that to percent, so the percent decrease is 55%. Now let's talk a little bit about abuses of percents. You always have to keep in mind what you're doing a percent of. And a lot of times people get that mixed up, whether they mean to or not. People will sometimes talk about a percent increase where they really have the wrong number in mind or something like that. So let's look at example 15. John Tesh, while he was still co-anchoring Entertainment Tonight, reported that the PBS series The Civil War had an audience of 13% versus the usual 4% PBS audience, an increase of more than 300%. Did he report the percent increase correctly? Well, let's see if we can calculate the percent increase and see if what we calculate matches what he said. So we know that the usual audience was a 4% audience for PBS. And during this special on the Civil War, we know that it jumped up to 13%. 13 minus 4 is 9, so that's an increase of 9 percentage points. Now, to get percent increase, we take the increase amount, which is 9 points, and we divide by the original number. So usually their audience was at 4%. It just went up for that special, but the original would be 4. So 9 divided by 4 is 2.25 in decimal form, but in percent form, that's 225%. Not quite the 300% that John Tesh reported, so he was incorrect. Now, I think what he did was he said 13 divided by 4 would be a number bigger than 3, so that would be more than 300%. But see, his mistake was you can't compare the 13% to the 4. You have to compare the increase. So the percent increase was 225%. Okay, here's another one, and we see people make this mistake a lot, so I want you to pay really close attention here. This one says, a politician states, if you elect me to office, I promise to cut your taxes for each of my first 3 years in office by 10% each year, for a total reduction of 30%. Evaluate the accuracy of the politician's statement. Okay, so what we're going to do to test the accuracy of this politician's statement is we're going to pretend that our taxes have been $1,000 each year. Okay, just to pick a nice round number. You could do this with any number. There's nothing special about the $1,000, but just to keep the numbers nice to start out with, okay? So now, if he cuts taxes 10% each year, let's see what happens. So the first year that he's in office, we're going to need to pay the $1,000 minus our 10% discount. So $1,000 minus 10% of 1,000, that would be 1,000 minus 0.1 times 1,000. So this would be a $100 discount. So 1,000 minus 100 is $900. So the first year our taxes dropped 10%. Okay, that's good. Now for the second year, what we would be responsible for would not be the $900 again, but remember he's going to cut taxes 10% each year. So we'll get a 10% discount off of this. So $900 minus 10% of $900. And so this time we get a $90 discount because 10% of $900 is $90. So $900 minus the $90 discount is $810. Okay, now for the third year, we are going to pay not the $810 that we paid last year, but $810 minus 10% of the $810. So that gives us a tax bill of $729 for the third year. Now you can see that each year taxes did decrease by 10%, but it's not 10% of the $1,000 that we started with, it's 10% of the previous year's tax bill. Okay, so that's why you see that each year this goes on, our discount is smaller compared to the year before. Now, what we want to do to evaluate whether he's correct about the 30% total is we want to get a percent decrease from where we started to where we ended up. So remember, to calculate a percent decrease, we first find the amount of the decrease. So the amount of the decrease would be 1,000 minus 729. That would be a $271 decrease. And then the percent would be this 271 divided by the number we started with, which is 1,000. And so that would be 0.271, which is a 27.1% decrease. Not the 30% that he promised. Now see, if he had given us 10% of 1,000 each year, then yes, we would have ended up with a 30% tax decrease. That's not what they do. It's 10% of last year's bill, and therefore the total percent decrease ended up not being the 30% that was promised, but just 27.1%. And again, this is a common mistake that people make with percent increase and percent decrease, and it's because the number that we're using as the base is changing every year. Okay, now let's look at example 17 together, and this is one that happens all the time, so I wanted to take a look at it with you. It says the price of a color printer is reduced by 30% of its original price. No problem. When it still does not sell, the price is reduced by 20% of the reduced price. The salesperson informs you that there is a total reduction of 50%. So the salesperson is saying 30% plus 20% is 50%. Is the salesperson using percentage properly? And if not, what is the actual percent reduction from the original price? Okay, so here's the problem. The first discount was taken off of the original price. That's the way it always is, and that's correct. The second discount was not taken off of the original price. Notice, and this is the way it always works, the second discount was taken off of the reduced price. And so you can't say 30% plus 20% is 50% because these are not percents of the same thing. It's 30% of the original plus 20% of the reduced price. Okay, so we can't add percents that way. In order to add percents, the bases must be the same. In other words, the percent has to be taken from the same number. If it was 30% of the original price and then 20% still of the original price, then we could say 30 plus 20 is 50. But it's not. It never is. So what we're going to do to find the actual percent reduction is we're going to say let X be the original price. It doesn't matter what it is, just let X represent the original price. Okay, so if you got a 30% discount from the original price, then you know that the discount is going to be 0.30 times whatever that original price is. So for us, 0.30 times X. Okay, so that means that the first sale price is the original price minus 0.30 times the original price. So that is 0.70 times the original price. And what I've done here is I've said this coefficient is a 1. So combining like terms, 1 minus 0.30 would give us 0.70. But you know that if you're getting a 30% discount, you're paying the other 70%, right? So this is not a surprise. Now for the second discount, we know that the second discount is 20% of the reduced price. So that's going to be 20% of this 0.7 times x. Okay, so to calculate this, we'll say 0.20 times 0.7 times x, and 0.2 times 0.7 is 0.14. So the second discount ends up being 0.14 times x. Now that's just 14% of the original price. So the total discount is going to be the original 30% discount plus the second discount, which was 0.14 times the original price. That's a total of 0.44 times the original price, and that's just 44% of x. So the total discount is 44% of the original price. Not quite the 50% that the salesperson thought, but again, their mistake was that the 30% and the 20% are not both percents of the same number. There are two different numbers involved here, and that's what's causing the trouble. And finally, example 18. So this is our last example together for this section. Suppose that you paid $1,200 in taxes. During year 1, taxes decreased by 20%. During year 2, taxes increased by 20%. What do you pay in taxes for year 2? So at first glance, you might think that, well, if they dropped by 20% the first year, and then they went up by 20% the next year, you might think that the two offset each other and we're going to end up paying $1,200 the next year. But that's not the case, because these two 20% are not both 20% of the same thing. So you always have to keep in mind 20% of what. And if they're not both percents of the same number, then they will not offset each other exactly. So let's just calculate here what we're going to end up paying in year 2. So we'll start with year 1. In year 1, taxes decreased by 20%. So we're going to get a little discount. So for year 1, our taxes would be the $1,200 that we paid last year minus 20% of what we paid last year. So that would end up being $960. For year 2, when the taxes increase by 20%, it's going to be the $960 that we paid last year plus 20% of $960. See, this time the taxes went up, so it's plus. All right, now 960 plus 20% of 960 is going to be 1,152. See, they went up, but they did not go up as much as they started out. So part B, how do your taxes for year 2 compared with what you originally paid, namely the $1,200? And if the taxes are not the same, find the percent increase or decrease. Well, we can see that they're not the same, and of course 1,152 is less than $1,200, so that's the answer to the first part of the question. And then they asked us to find the percent increase or decrease. Well, obviously it's a decrease because we are paying less than what we started out with. So first we have to find the amount of the decrease, and that would be the $1,200 minus the $1,152, which is a decrease of $48. And then when we find our percent decrease, we always compare to the original number. Well, the original number was $1,200. So the total percent decrease is the $48 decrease divided by 1,200, and that is 0.04. And when we convert that to percent, that gives us a 4% overall decrease in our taxes. Okay, I hope that now at the end of this section that you feel a little more comfortable with percent than you did at the beginning. I know that percent can be a little confusing for us. I'm going to blame that on the way that we teach percent to you when you're in middle school. So if percent was always confusing to you, don't worry. Really, the reason is that when we teach it to 6th and 7th graders, they're really too young to fully grasp it. They haven't been out in the world and had to buy a sweater on sale or anything like that. So if you have always been confused by percent, give yourself some grace. Practice with it. It is not hard. You are an adult. You can do this. and you are going to be perfectly fine. You just need to practice and get comfortable with it. You've got your calculator with you, so be sure and practice and ask questions if you need to. And I will catch you guys in the next section. Bye now.